Hey guys, Mr. Patterson checking in with our second video for section 23D for IB Math SL. We're going to look at the binomial probability distribution function. We're going to look at the equation that we use to find probabilities, but we're also going to talk about how the graphing calculator can help us out in finding these probabilities. So to start off here, it says, consider a binomial experiment, which we talked about in the last video. The conditions are, if you need to check back on that, go ahead and do so. But if you have a binomial experiment where p is the probability of success, and therefore 1 minus p is the probability of failure, we can then find the probability of getting r successes, and therefore n minus r failures, by saying probability that x equals r is n choose r, which I can show you in the calculator how to get that again in just a moment, times p to the r times 1 minus p to the n minus r, where the values of r are 0, 1, 2, 3, all the way up to n. And when we do that, we say the probability that x equals r is referred to as the binomial probability distribution function. Because if we plugged in the n, the p, and the r values, we can then go ahead and find the probabilities for that particular value. The mean, or the expected value of the outcome, E of x, or mu, is equal to n times p. And therefore, we can define the random variable. We say x is the random variable of the binomial experiment with parameters n times p and np, excuse me. We write it as x is distributed as the binomial random variable, and the parameters we need to state are n and p. Because if you know n and p, then you can find anything you need about that problem. So let's take a look at this example. We're going to take a look at it first using the formula that we just talked about, and then we're going to talk about how to get it from the calculator. So this example says 72% of the union members are in favor of a certain change to their conditions of employment. A random sample of 5 members is taken. Find the probability that 3 are in favor of the change. So if we look at that there, first of all, we know x is distributed as a binomial distribution. N is 5, p is 0.72. So if I'm looking for the probability that exactly 3 of them are in favor, I do 5 choose 3. 0.72 to the third, that is p to the r, and then 1 minus 0.72, which is 0.28, to the n minus r, which is 2. And then I can plug that into the calculator and I get about 0.293. Question B says the probability that at least 3 are in favor. Well, if I did at least 3, that's 1 minus the probability that 2 or fewer are in favor. So I could do the same thing. I could plug in for 0, for 1, for 2, and add those all together. And when I do that, I get about 0.862. And question C is asking for the mean number of the members of the sample who are in favor. So that's just n times p. 5 times 0.72 is 3.6 members. Now, I know you can't actually have 3.6 members, but we don't round. We still keep our decimals there, because if we were to change certain aspects of it, we want to maintain that accuracy as we go through. All right. Now, like I said, the graphing calculator can help you. If you're trying to figure that out, we use what's referred to as the binom PDF and the binom CDF functions in the calculator. So let's go back and look at that, the previous example using the graphing calculator. So I open it up, and I'm going to go, when I hit the second distributions menu. I say distributions because that's the actual tab we're getting into. It's really the vars button is what we're hitting, but we're hitting the second function, so therefore it's the distributions menu. And we see a few things in this menu here. We're not going to use them, the top ones here. We will use some of these eventually, but we're going to scroll down. And here we see in A and B, binom PDF and binom CDF. Now, question A was exactly 3 successes, so that's a binom PDF scenario. If you're looking for exactly a number of successes, that's PDF. And then it asks us just to enter in these n, p, and x values. So n is the number of trials. We have 5 trials that we're observing. The probability of success was 0.72. And we wanted to know the probability of getting exactly 3 successes. So we hit paste, and we hit enter, and we see that same 0.293 value that we got previously using the formula. Now the second question asked for at least 3. At least 3. Well, I could do binomial PDF for 3, for 4, and for 5 and add them together. That is a little bit time consuming. But like I said, we could also do 1 minus the probability of 2 or fewer. So 1 minus the probability of 2 or fewer, I'm going to hit the second vars, or the distribution menu again. But this time I'm going to select binomial CDF. It's still 5. It's still 0.72. 72? I think it's 72. Let's double check that. Yep, 72. And in this case, since I want 2 or fewer, I'm going to put 2 here. And because it's the CDF for C for cumulative, that allows it to find, okay, I'm finding 0, 1, or 2. And since I'm doing 1 minus this, it's actually going to give me 3, 4, or 5. And I get that 0.862 that we saw on the slide previously. All right. The reason we have to do 1 minus here is because binomial CDF is a left-tailed probability, meaning it can only find a value less than or equal to a certain number. It can't find greater than values there. All right, so you always have to do the 1 minus there. All right, let's get back to our presentation. All right, and that's it for this lesson here. Another quick lesson going through binomial probabilities. For the assignment, I'd like you guys to work on page 622, numbers 1 through 13 odd. All right, have a great day, guys. Take care.